I want to take a minute here to just go over circles and their equations. Circles are actually pretty easy. You're gonna, just like with parabolas, when you're graphing this on Desmos, you're gonna have to play around with the numbers a little bit. But this is what the general formula for a circle looks like. Let's see here. Let's use a dark color. So the general formula for a circle would look something like this. It's x, so that's the variable that stays there, minus h squared plus, and then y minus k squared equals r squared. That's what it looks like. Again, let me just kind of talk a little bit about what you should expect to change here. So h, k, and r, again, are variables that are placeholders. That means that you're supposed to replace those with numbers. I'll abbreviate their numbers. But there is a significance to each one of those variables. Now I have a circle here drawn. I drew it beforehand because it's a little easier to make out, or it's better drawn, I guess I should say. So h and k are the center of the circle. It's the point right on the center. Remember that a point on a graph requires two coordinates, an x and a y coordinate. And so h is the x coordinate of the center, and k is the y coordinate of the center. And so if I look at the circle that I've drawn, the center is right there. And so h would be 1, 2, 3, 4 to the right, and k would be 1, 2, 3 up. And so the coordinate of the center for the center of this circle is 4 units to the right, 3 units up. And that is what h and k are. So we're going to replace h and k with 4 and 3. And then the r, that stands for the radius of the circle. And to get the radius of any circle, all you have to do is, from the center of the circle, count how many squares you have to travel to the edge. And so here, I would have to go 1, 2 units to get to the edge of the circle. That's the radius. You could also go in the other direction, like right there. That's also 2 units. That's also 2 units. This is also 2 units. In any direction, really. Now, what is important is that you go either in a horizontal, that means in a sideways direction, or vertical, that means up and down. Because when you go sideways, horizontally, or up, down, vertically, you can count the number of squares straight from just what you count. So like right here, if I go from the center, I go up, that's 1 square, and then that's 2 squares, and so the radius is 2. However, if I go at in a diagonal, which is like at an angle, if I go from here in that direction, it's not exactly 2 squares, and so that would give me a false reading. It is, the radius is 2, but if I go at an angle at a diagonal, I might think that it's less than 2. Remember that when we have diagonals, to get the length of these lines, we use the distance formula. And so count sideways or up and down. That's your best bet when you're getting the radius. And so I'll write here that the radius of this circle is 2. And now we have an equation. It's a very simple equation here that we can write for this circle. It is, I'm going to write it down here. So the equation for the circle is x minus, and I'm going to color code this. So I'm going to just continue with the template, plus, and then a y minus equals like that. And so we have in green here, we have the center at h. So h again is 4. So I'm going to put x minus 4. And then k, this 3, k goes right there, so I'm going to put y minus 3. And so those two are squared. And then finally the radius is 2. That's basically how big the circle is, and so I'm going to put 2 squared. The radius goes right there. Now you can, if you want, you can square the 2, and that 2 times 2 is 4. So you could instead put 4, but I am going to suggest that you keep this format, because then if you want to change the radius, all you have to do is change the number inside, or not the number inside, but this 2 right here in red. If you increase that to 3, it's going to make your circle bigger. If you would make it smaller, like 1, then it makes your circle smaller. One thing to note, and I'll make sure I point this out on Desmos when we're graphing this, because we're going to graph a few. One thing to note here is that if you change that number, the h, you're going to move your circle sideways, left and right. If you change that number, the 3, you're going to move your circle vertically up or down. So that's the effect that these values have on the formula. Now let's take a minute here to graph a few circles on Desmos so you can see what that looks like. And then we can also maybe incorporate some circles on our drawing. Okay, so let's see. Let me go to Desmos really quick. Desmos, recall that you must sign in. And when you we start graphing. Sign in. When you sign in, use your student Gmail account. In my case, I'm going to use my teacher account. You go here and you look for your graph. Right there it is. But I am going to make a new graph, and I'm going to call this circles. So we can play around with circles and you can see what they look like. So I'm going to start by placing a point here somewhere. Maybe -4. -4, that's 4 to the left, and then -2. That's 2 down. I want to put a label here and call that the center of the circle. And then I'm also going to put make a radius here, a variable. You can just make a variable by putting the variable name. So in this case, r for radius equals, I don't know, something like 2. Notice how it makes a circle there. That's a little odd. I don't think I've played around with this before. I think it's just making a circle at the origin. Let me try something else. Let me, instead of r, use a equals 2. I guess, notice how when I put a, it didn't make a circle. I think with Desmos, it recognizes r to be the radius of a circle, and so it makes the circle. And so the general formula is x minus h. H is the x coordinate of the center. In that case, it's -4. And so I would put x minus a -4. And then I would square that. And then I would put plus y minus k. K is -2, so -2. And then I would square that. And then I would put it equals the radius, in this case a. Or if you want, you could put 2 and squared. And so notice how it draws my circle centered at this point. Now I want you to note here that when the coordinates for the center are negative, as they are here, -4 and -2, then this is actually going to be negative x minus a -4, which is the same as x plus 4. And y minus a -2, well, that's the same as y plus 2. And so when the coordinates of the center are negative, in the formula itself, it becomes a plus instead of a minus. And so I guess a good way to think of this is when this is positive, you're going to the left. When this is positive, you're going down. And when it's negative, you're going to the right. And when it's negative, you're going up. Now let me again introduce some variables here. Instead of -4, I'm going to put a k, and instead of -2, I'm going to put an h, and I'm going to add a slider for both of those. So notice how it just gives them an initial value of 1 and 1, and I can make those numbers bigger or smaller, and it moves the point. It's still called the center, and I'll put it there at 2. And instead of x plus 4, I'm going to put x. Remember that it's the formula is x minus k. Instead of y plus 2, I'm going to put a y minus h. Now see how the circle is centered at this location. And instead of 2 squared, I'm going to put a squared. And so if I increase a, it makes my circle bigger, right? That would be like 6 squared. 6 to the power of 2, that's 36. However, the radius is 6. If you count, it's 6 units. If I play with this, the h, it moves the circle up and down. That's my son talking about monkeys. And then if you move this, you move the circle sideways, left and right, the k. And that's what these variables h, k, and r do to your circle. They move them, they move the circle, the center of the circle, and they increase the radius or decrease the radius. Let's say if you go negative, it actually has the same effect, because when you negative times a negative is a positive. So if you want your circle to be really, really small, you make it a small number like that, 0.5. If you make it 0, then your circle becomes a point. Now, how do you get a portion of the circle only? Well, you can still restrict the domain. Let's say I only want the right half of this circle, just the right half. Well, then I want to say I want my circle, but only for x values that are more than 4. Notice how here you have 4. And I can actually draw a dashed line, x equals 4. And I can, if I press and hold here, I can make it a dashed line. So notice here the x value is 4, and if to make a vertical line, I put x equals 4. Say I only want the right half of this circle. Well, in my formula here, I would restrict the domain, and I would say I only want x values that are greater than 4, like that. Well, what if you only want, okay, now you have the right half. What if you only want the top half of this half of the circle? You only want the top half. You don't want this bottom half. Well, the center right here goes through 5, and so right here in the same space here, I can restrict the range and say that I want my circle for values of x bigger than 4 and values of y, I said at the top half, you want the top half greater than 5. Where y equals 5, and let me put it here, is that line right there. It's pretty cool, right? And so now you have only a portion of the circle, which is convenient because you might need to only have a portion of the circle. And let me show you one last thing here. Let me erase these 2 lines. Let me erase this restriction on the range. That's how much you restrict the circle up, down, and this is the restriction on the domain. You restrict the circle sideways. I know that because this is x and that's y. So domain is x, range is y. So if I delete that, I get my whole circle. What if maybe I have some parabola, and let me put a parabola here. Let's recall with parabolas, the first thing we want is to locate the vertex of the parabola. Let's say for now, let's say that it's 5. Let's say 1 to the right, 5 up. That's actually right on the circle. Okay, that's fine for now. I'm going to label this as a vertex of the parabola. And recall that for parabolas, the general equation is y equals, and then x minus, again, h, which is the x coordinate. That would be a 1. And then we square that. And then plus k, which again happens to be the y coordinate of the vertex, so that would be a 5. And if you don't recall this, just take a quick look at our video on parabolas. Well, let's say that you want this, right? But you only want it, I don't know, we can restrict the domain. So here we have 1. So we want the parabola between an x value of 1, and then here 2.63. Let's just go to 3. So I'm going to say here for between 1 less than or equal to x less than or equal to 3, like that. So maybe you have like the eyebrow right here, and then this is the eye. Now let's suppose that what you want is that you want you don't want this portion of the circle right here. All right, there's the center. What you can do is you can take all this, which is the equation. I think I can, if I do Control C, it should copy, and I'm gonna paste it here. There it is. Now it does there's something funky here, but well, okay, it works, right? Let me actually go ahead and delete this. I want to try something. Haven't tried it before, but I'm gonna, instead of putting equals, I'm gonna put minus, and then I want to put here equals 0. Okay, that works. All I did here is I subtracted the a squared to the left side of the equal sign, which can always be done in equations. So like if you have this equation here, what I did, and you can do this, is I said I'm gonna move this term. I'm gonna move that term to the left side, and I do that by subtracting. So if I have x minus 4 squared plus y minus 3 squared, and then I'm gonna subtract 4 to both sides, minus 4 minus 4. Then I would put here minus, but instead of putting as 4, I'm going to put it as 2 squared, equals, and then 4 minus 4 right here, 4 minus 4 is equal to 0. And so you've effectively changed how it looks a little bit, the equation, but you have not changed what it does. It still graphs the same circle. And so moving that to this side is what I've done here on Desmos. So notice how instead of putting the a squared after the equal sign, I subtracted it to the left side of the equal sign, so it's now a negative, and then I put equals 0. And what I'm going to do here is I'm going to replace this 0 with this equation, this for the parabola. So I'm going to copy this, and I'm going to take that, delete it, and I'm going to paste it here. And what I'm going to do is I'm going to change this equals to a less than symbol. Let's try greater than. And it's not doing what I want it to do. It's doing something pretty crazy there. Okay, what I was expecting it to do was to give me the circle, just this portion of the circle. All right, so what I was suggesting is not going to work, but there is a workaround here. What I can do is I can look at this point of the vertex of the parabola, and its y-coordinate is 5. Here it is. And so if I want a line that goes through the y-axis at 5, I can put y equals 5 there, like that. So I'm just kind of giving myself an idea of where I want. I don't want this part of the circle, right? And then right here, the other point where the parabola crosses the circle, I'm looking at its x-coordinate, 2.634. And so I'm going to make a vertical line that goes up and down and that you do that by doing 2.6 x equals 2.634, and there it is. And what I'm going to do now is I'm going to have to do two circles, and they're like overlaid. So I'm going to say that I want my circle for x values more than 2.634. So right here I'm going to put here for x greater than 2.634. And notice how it gives me here, that's this vertical red line. I'm getting the circle only for x values more than that. So x values more than 2.64 would be 4, 6, 8. And so I only graph the circle, this right portion right here. But I'm missing this part. And so what I'm going to have to do then, and this is one way of doing it, it's not the only way, but if you go here to settings, which is actually something I haven't discussed, you can duplicate this. So you can click here, duplicate the formula. And now, oh, that's not the one I want. Right here, the circle. You can duplicate it, and now you have two circles, right? And so I'm going to click done. And then on the second circle, what I'm gonna do, I'm gonna get rid of this domain restriction. Notice you get the whole thing. What I want is the bottom half of the circle. So I want the circle for y values less than 5. So here's y equals 5. It's this black line that goes here. I only want the bottom half of the circle. And the way you restrict the range, it's up and down behavior, is by putting y less than 5. And so now you have the bottom half. And for all purposes, you could actually say that this is well, this is the desired effect. Now notice how you get this half. If I actually erase that, you see how it's the whole bottom half. And if I get rid of that, so why don't I have this circle, and let me change the color just for a minute so you can see the effect. Let me put red. You have this green circle that goes up to here. It goes all out of that. And then you have this red circle that's a semicircle, it's half a circle. I'm going to have this circle in red, I'm going to have it just go from here to right there. And that's easy to do because I already have the bottom half. It's y less than 5. I'm going to say that my x values are going to be less than 2.63, so to the left. And so that's only going to graph this portion. And I'm going to say I'm going to restrict the domain for x to be less than 2.634. And now my red only goes up to here. And if I then change the color back to green, it almost acts like they're the same circle. And there's no way to see where there's the disconnect is here. Let me hide these away, and now you see you kind of have this, you have this circle, but you don't have it everywhere. I can at this point maybe get rid of the vertex so it doesn't show up there. And now you have a circle that you could use. Let me save this for a minute. And let me go in here and open this graph. And if I look here at, you see here there's a circle, but the circle itself is not a full circle because the eyebrow goes right through it. And so when I make this circle, I would want not the entire circle, only a portion of the circle. And you can use this formula now. The first step with the graphing the circle would be to identify where the center is going to be at. And at first you can try to eyeball it, that's okay. It's okay if you don't get it exactly where it's supposed to be. But from here, every square is half a unit. And so it seems to me like this is 2. I have like 2 squares to the right of that, so that would be 3. And then you have 8, and then 9, maybe like 9.5. So I would put here a point, 3 to the right, 9.5 up. And it doesn't look quite like it's right on the center. Let me try something. Let me try a little higher than that, 9.8. That looks much better. It actually also looks like I have to go to the right a little bit. So let me do, instead of 3, let me do 3.2. That seems 3.2 there. Okay, that looks much better. And so now you can think of that as the center of the circle. I can label this. I can call it center C1. And then I can use my general formula. So the general formula says x minus h. H is 3.2. That's the x coordinate of the vertex. And remember to put the little exponent, you use the shift and the number 6. Shift 6 at the same time, squared. And then you do plus y minus h. H is 9.8, so you put 9.8. And then you once again square that, equals, and the radius, you can also count, try to eyeball it from here. How much do I have to go in this direction? Well, that looks like 1 and maybe 1.5. Let me try 1.5. And you guess and see if that's big enough. Remember that you have to put the squared. It's pretty close. It looks to me like maybe I would have to go a little higher, so 1.8. That's a little maybe too much, so 1.7 is like practically spot on. I'm gonna move my circle a little bit to the left, and if I want to move to the left, I decrease the x coordinate here, so maybe like 3.1, but I also have to do it here, right? Because that's where it actually moves it. Perfect. And so now you have your circle, but you only want it to go, you only want this portion of the circle kind of like the bottom portion, because you don't want this part of the circle that is on the eyebrow. And so I would suggest that you maybe with your mouse click right here and look at the x coordinate. So the x coordinate right here is 1.414. And so I'm going to put it here for x values less than that, because we want the circle below this point. So for x values less, oh, I'm mistaken. When we're trying to restrict the circle up or down, we look at the y coordinate, in this case the 10. And so I'm going to say for y values less than 10. Notice how I only, that's if I drew a line, horizontal line sideways at 10, I'm also cutting off this portion of the circle, so I'm only getting y values less than 10. But that's where you can do what I suggested, which is duplicate that. Now you have two circles, done. And right here, instead of y values less than 10, let me erase that. Let's say that we want it to stop here, and so for x values bigger than 4, and I was looking at the x coordinate here, 4, right? So if you look at 4, you want the right side of that circle. So I'm going to put here for x values greater than 4. And then if I want, because they overlap right now, if I don't want them to overlap, I can say for x values more than 4, so that would be to the right. And then right here where they intersect at 10, I can say for y values more than 10, because, oh, I didn't want to do that. Control Z as in zebra undoes when you accidentally delete something. Let's put here for y values greater than 10. And there you go, you have a circle for the eye. If you want to color in the circle, I guess that's a thing that I can comment on here. You can change, instead of equals, the radius squared, you can put less than or equal to, and it actually shades the circle in. Less than or equal to. Oh, this only works, so that quite doesn't work, right? There we go. We'll just leave it like that for now. Okay, let me zoom out a little bit here so you can see what that looks like. Let me hide let's hide our image, and there's the circle right now. So it's starting to take shape. Make sure you save your graph before you exit this out.